What would you see? What would you feel at the exact moment you cross the threshold of no return of a black hole? A place where time stands still, light is suffocated, and matter is rewritten. Every civilization, every inquisitive mind has asked the same question: what lies on the other side? Is it an end, or is it a beginning? This is what would really happen, step by step, if you were to fall into a supermassive black hole. A journey where destiny is not a place, but a moment in time. But before crossing that frontier, we must understand the beast. Its name is deceptive. A black hole is not a physical hole in space. It is simply the ultimate remnant of a massive star. Imagine a star weighing 20 times our Sun. When this giant exhausts its nuclear fuel, it loses the pressure that counteracts its own immense gravity. Is a collapse in fast forward, a process nature has perfected. The result is a supernova explosion so violent it illuminates entire galaxies, but it leaves behind a core, a heart that continues to contract. Its own weight overcomes every known force, crushing matter without mercy. Matter is compressed to a point of incomprehensible density. Gravity becomes so colossal that it not only attracts but warps reality. What we call gravity is, in truth, the curvature of space-time. And upon reaching the singularity, it bends towards infinity. Gravity's game has one final rule: the speed required to escape this pull increases. It keeps rising, relentless, until it reaches a limit that no object in the universe can exceed. What is that limit? It is the speed of light. This is the point of no return. What does not allow light to escape will certainly not allow time or information to leave. It is the threshold that separates our universe from non-existence. This invisible and absolute barrier is what we call the event horizon. It is not a wall, it is the mathematical point where our physics surrenders, and once you touch it, your fate is sealed. The journey has begun, but there is a cruel irony for you, the traveler. The beginning is indistinguishable from the end. You feel nothing. The ship, or your own body, floats towards the abyss. The stars in front of you intensify, becoming brighter, as if the universe were concentrating into a single point. Behind you, the light from distant galaxies stretches and fades into a horizon of red and blue dots. But for a distant observer, what happens to you is even more unsettling. To them, your journey appears to slow down. Your image freezes, your light dims, turning you redder and redder until you finally become invisible. To them, you never actually cross. You become a ghost halted at the threshold of time, a shadow frozen in the veil of infinity. Physics is fickle. Your time and theirs are now separate worlds. And so, in a blink imperceptible to you, and an eternity to them, the event horizon absorbs you. You are no longer in the universe as we know it. You are inside. Inside, the universe you knew is compressed. The sky no longer exists. Space no longer has fixed dimensions. The reality outside has collapsed into a tiny point of light behind you. There is only one possible direction, forward, towards the center, towards the singularity. The singularity is the heart of the black hole, a mathematical point of infinite density and curvature, where all mass is concentrated and all the laws of physics we know simply cease to function. What we see, what we feel, is nothing more than the consequence of extreme space curvature. In fact, as you fall, the light around you bends to the point where you could actually see your own back, or the light coming from the rear of your ship. The universe becomes an optical hallucination of twisted light. But, in this supermassive black hole, the vastness of its event horizon allowed you to cross painlessly. The disintegration, however, is inevitable and begins now. The gravitational force is so extreme that its pull is not uniform. That is, the gravity at your feet is vastly stronger than at your head. This gradient is what we call tidal force, and it is unstoppable. You would feel the acceleration increasing, not like an engine, but as if space itself were stretching. If you could remain conscious, your body would begin to elongate progressively. Your physical structure would stretch like cosmic spaghetti. Forces would overcome the resistance of your molecules. Your bones would pulverize. Your atoms would disintegrate. You would become a razor-thin strand of matter, undone by cosmic tides, dragged towards the central oblivion. And here lies the deepest truth. Inside the horizon, time and space have swapped roles. Outside, you could move through space, but time marched on. Inside, the singularity is no longer a place you can choose to avoid. It is a moment you must reach. It is, inevitably, your future. You cannot avoid the future, and you cannot avoid the singularity. Every nanosecond spent inside the black hole brings you one step closer to total oblivion. The final sensations would be brutal acceleration and the total distortion of reality, just before your existence comes to a complete end. There is no escape. There is no light. Only the certainty of the final disintegration of matter into a point with no dimensions, no time, no past, and no future. The absolute end for matter as you know it. However, if there is one final promise, it is found in the information you once were. Although your body disintegrates, the history of your particles might not be erased. And here, at the edge of annihilation, lies the last great mystery of our cosmos. Einstein's general relativity tells you that you have disappeared forever. But what does quantum physics say? That voice which governs the laws of the tiny. Quantum physics dictates an inflexible law. Information is never destroyed. If you have been disintegrated, your existence has not been erased, merely transformed. Where did the quantum footprint of your original self, the sum total of your particles, go? This is the monumental black hole information paradox, the collision point of the two great theories of the universe. The most accepted solution gives us a promise, the holographic principle. This postulates that your quantum information was not swallowed, but encoded on the two-dimensional edge of the event horizon, like an immense cosmic memory. And that information has an exit, Hawking radiation. As the black hole slowly evaporates over eons, your information will be released gradually back into the cosmos, although likely in a form so scrambled and unrecognizable it would be impossible to reconstruct. Your existence, therefore, does not end, but disperses back into the universe, honoring the law of conservation. Or the boldest hypothesis, the one that ignites the imagination. Could it be that supermassive black holes offer a doorway? Theoretically, they could be an Einstein-Rosen Bridge, a wormhole connecting to a white hole in another cosmos. Although these mathematical solutions are immensely unstable and science leans towards the preservation of information, the dream of a journey to a completely new universe, where the rules are rewritten, is the last hope that physics has not yet managed to fully close. We have traveled to the edge of reality, where matter disintegrates and time stops. We have faced the certainty of cosmic annihilation and the enigma of lost information. But this is the most beautiful truth of science. Every time the universe tells us you cannot pass, the human mind responds not yet. In every unanswered question, there is a promise of future knowledge. The darkness of these cosmic giants is not the end. It is a mirror. It encodes not only the future of matter, but also the tireless curiosity that drives us to unravel the deepest secrets of existence. The black hole is nature's ultimate challenge. And it is our destiny as explorers of the cosmos to keep searching. If astronomy fascinates you and you want more journeys into the unknown, subscribe to AdagioZero and explore with us the limits of reality.